So good day, I am Jack Sanchez and I'll be introducing a blockchain along with telling its history. So blockchain technology introduced in 2008 by Satoshi Nakamoto is a decentralized and secure method for storing data. It operates as a distributed ledger, recording transactions across multiple computers, ensuring no single entity controls the system. This makes blockchain resistant to tampering and fraud. Nakamoto's white paper, Bitcoin, a peer to peer electronic cash system, outlined the first practical use of blockchain. Bitcoin, which launched in 2009 as the first decentralized digital currency. So, initially linked to Bitcoin and cryptocurrencies, blockchain technology has expanded beyond digital currencies. Business now use it to enhance security, transparency, and efficiency in record keeping across various industries. Applications like decentralized finance, non-fungible tokens or NFTs, and smart contracts have shown blockchain's versatility in finance, healthcare, supply chain management, and entertainment. Excuse me. Today, organizations and governments recognize blockchain as a transformative force reshaping business operations and data management.
Hey everyone, my name is Chai, and today I'm excited to talk about blockchain technology and its key features. In this discussion, we'll break down blockchain technology into three main parts: the theories, concepts, and key features. First, we'll look at the theories behind blockchain, which explain how it works and why it's designed to be secure and decentralized. Think of it as like the rules of a game that everyone has to follow to keep it fair. Next, we'll dive into the concepts of blockchain, which are the basic building blocks that make up this technology. We'll talk about what a block is, how transactions are recorded, and how computers in the network help confirm those transactions. Finally, we'll highlight some key features of blockchain that make it special. This includes things like how information is shared across all computers in the network, how users can send money directly to each other without banks, and how the system stays secure. By the end of our discussion, you'll have a clear understanding of what blockchain is and why it matters in our digital world. Let's discuss the theories. So, what is a blockchain? Think of it as a digital ledger, like a notebook, that securely and transparently records transactions. Unlike traditional ledgers controlled by one person, blockchain is maintained by a network of computers called nodes. This decentralized structure prevents any single entity from having too much control, similar to how Bitcoin operates without a bank. Once data is recorded on the blockchain, it's nearly impossible to change. This is due to cryptographic hashing. Each piece of data is transformed into a unique code through a hash function, which includes the hash of the previous block, forming a secure chain. If someone attempts to alter a block, its hash will change, breaking the chain and altering the entire network. For instance, if a transaction in Bitcoin is tampered with, the inconsistency is immediately detected by the network. To ensure all nodes agree on the data, consensus protocols are used. In proof of work, which Bitcoin employs, miners compete to solve complex mathematical puzzles. A transaction is added to the blockchain once the majority agrees on its validity, much like a group project where everyone must reach a consensus before submitting their work. Every transaction is publicly recorded, meaning anyone can view the details, which promotes transparency and trust. For instance, if every purchase you make was visible to the public, it could help ensure honesty in the system. Smart contracts are automated agreements written in the code that execute automatically when specific conditions are met. Picture a vending machine. Input the right amount, and you get your snack. In real estate, a smart contract could automatically transfer ownership once payment is confirmed. Another essential component is public and private keys. Your public key acts like your home address for receiving packages, while your private key is the key to your front door. And together, they secure transactions and verify ownership. Now, let's highlight some key features of blockchain. One major advantage is data replication across all nodes. If one node goes offline, others still have copies, keeping the network operational. For example, if a Bitcoin miner's computer crashes, other miners still have the transaction data. In POW systems, miners who solve puzzles and add blocks to the chain and earn cryptocurrency as a reward. This allows users to interact directly without centralized authorities, such as banks. For instance, sending money to a friend in another country can be done directly with Bitcoin, avoiding hefty fees. And sometimes, forks occur in blockchains. A soft fork is a backward compatible change, while a hard fork creates a new version of the blockchain. A notable example is the split between Bitcoin and Bitcoin Cash in 2017, which aimed to increase transaction speed and block size. Let's delve into some core concepts of blockchain. Each block has three main components. First is the data, which contains the details of the transaction, such as the sender, receiver, and amount. For example, Alice sends 1 Bitcoin to Bob. Alice is the sender, Bob is the receiver, and 1 Bitcoin is the amount. And two is the cryptographic hash, a unique code generated from the block's data like a digital fingerprint. Number three is the previous block's hash. This links the current block to the previous one, creating the secure chain. Various consensus mechanisms validate transactions. In POW, miners must solve puzzles to add new blocks. They find a number, called a nonce, that, when hashed, yields a result below a specific target. Conversely, proof of stake selects validators based on how much cryptocurrency they stake. This method is more energy efficient and doesn't require solving complex puzzles. And lastly, let's talk about the pros and cons of blockchain. First is security. The decentralized nature and cryptographic hashing makes altering data very difficult. A hacker would need over 50% of the network's computing power to change a transaction, which is nearly impossible. In transparency, every transaction is publicly recorded, allowing verification. This is crucial in industries like supply chain management. Next is efficiency. Blockchain can expedite international payments. Services like Ripple allow money transfer in seconds. Reduce costs. By eliminating middlemen, transaction fees drop significantly. And lastly, automation. Smart contracts automate processes like transferring ownership in real estate. Next, the disadvantages of blockchain. First is scalability. Many blockchains struggle with high transaction volumes. Bitcoin's limit of about 7 transactions per second can lead to delays and higher fees. Next is energy consumption. POW systems like Bitcoin consume massive amounts of energy, raising environmental concerns. And next is the complexity. Understanding blockchain can be complicated, deterring new users. Next is regulatory uncertainty. Governments are still figuring out how to regulate cryptocurrencies, leading to confusion. And lastly, storage needs. Blockchain requires significant storage. Running a full Bitcoin node needs several hundred gigabytes. So, in conclusion, blockchain is an innovative technology that offers a secure and transparent way to manage transactions. Despite its challenges, it has the potential to revolutionize how we think about money, contracts, and trust in digital age.
Hi guys, I am Althea and we will explore the key techniques and strategies that make blockchain a groundbreaking innovation in the digital world. One of the fundamental techniques of blockchain is cryptographic hashing. This converts data into a fixed length string of characters, making sure that even the smallest change in the data creates a completely different hash. This ensures data integrity, meaning once something is recorded in a blockchain, it cannot be altered without detection. Next, we have Merkle trees. This allows quick verification of large amounts of data by breaking down and hashing data into smaller chunks. This structure enables a blockchain to verify individual data pieces efficiently, which is especially useful when we need to validate transactions across a distributed network. Another game changer is the concept of smart contracts. These are self-executing contracts where the agreement terms are directly written into code. Once predefined conditions are met, the contract automatically enforces the terms, eliminating the need for intermediaries. At the heart of blockchain is decentralized consensus. Unlike traditional centralized systems, blockchain relies on participants across the network to validate transactions, techniques like proof of work and proof of stake, and to ensure that no single entity controls the network. Blockchain also brings tokenization, which is the process of converting real world assets into digital tokens. This allows fractional ownership and easy transfer of assets like real estate or stocks, opening up new possibilities for digital marketplace. Another critical strategy is the ability for different blockchain networks to communicate with another. This is key for ensuring seamless data sharing and transaction across platforms, a step toward a more connected digital economy. When implementing blockchain, it's important to understand the difference between public and private blockchains. Public blockchains, such as Bitcoin, are open to anyone to join. In contrast, private blockchains are permission restricting access to select participants, making them ideal for enterprises that require more control and privacy.
Hello, my name is Jacob Francisco, and today I will talk about the future directions of blockchain technology. Although blockchain technology is still in its early stages of development, there is a lot of room for future developments and possibilities. Blockchain is expected to play a significant role in the digital world as various industries discover its potential and capabilities. Several emerging developments are set to shape the future of this technology, such as scalability improvements, energy efficient consensus mechanisms, interoperability between blockchains, integration with emerging technologies, regulation and legal frameworks, blockchain for social impact, and many more. To conclude, blockchain technology has already proven its ability to affect industries ranging from finance to healthcare. Its security, transparency, and decentralized nature make it a great solution to various problems in the digital era. As the technology evolves, addressing current issues such as scalability, energy consumption, and interoperability will be crucial for its long term success. Furthermore, blockchain's potential to integrate with other technologies and drive societal change opens new possibilities for its use. Blockchain has a bright future ahead of it, and with further development, it may completely transform the way data is shared, stored, and protected going forward, resulting in a more decentralized, transparent, and effective global economy.